Hello, this is Benjamin Meinger, a member of the Using Ocean-Going Robots to Observe Wave Conditions team, specifically the CS team, and today we're going to be talking about the Directional Visualization Framework and the requirement that's tied to that block in our system, the Directional Wave Spectra Visualization requirement. Basically, this requirement states that we need to accurately depict directional wave spectra using polar plots. These plots illustrate period, direction, and energy density of swells acting upon the glider. And basically, before we actually get into this testing process, I want to quickly talk about the key role that this module plays in our system. So essentially, this is one of our main outputs. So after we've processed our raw data and prepared it in a directional spectrum, we can display it and actually show things like you see here. So this is CDIP. This is basically going to be my reference. So we're going to be comparing the same data and just showing that the visualizations actually do represent the data with the same kind of pattern, so we don't have any discrepancies. So let's actually look at how I'm doing this. So essentially, this is our script. This script can both be called individually, but it can also be used just as an import library. So this polar plot function can be imported and can be used elsewhere. But for this demonstration, we're just going to be calling the script from the command line, and we're going to be passing in these CSV files. I already pre-prepared these. These all link up with these. And basically, we can view this data directly from CDIP here, and we can just import it. So let's start. Actually, just a little bit more information here. So we're using the matplotlib library to actually produce these visualizations, and there's kind of a lot of fancy stuff going on in the background, but I think the most important part to understand is this contour function. Basically, we set up a color map that kind of illustrates like the thresholds of the data, and then we can actually plot it, and we'll get right into that. So let's start with station 189. So from here, we can simply just call this function. We're in this directory. This is our script. These are the 5 data sets we'll be using. So we do python polar.py final underscore 189.csv, and we'll get a plot from there, and then we can actually compare these. So you can see that the pattern is the same. We have these swells here, and they're in the right place. They're at the right period. The general shape of the plot looks the same, even down to like some of these kind of really small lines out here. You can see them here as well. And I think it's also important to note that our energy density is the same. So let's move on. So that was our first trial done. Now we'll go on to station 122. Or sorry, 121. And again, another nice spectrum. And here again we can see the swells are in the right places. The general shape is the same. The energy density is the same. So let's keep going. That's trial 2 done. And now we'll do station 197. Alright. So again, we have this same swell here. We even have these kind of cascading swells increasing in period, or actually decreasing in period, increasing in frequency, I should say. So that's trial 3. Let's keep going. station 139 or 239. I also tried to pick some kind of more complicated spectrums. So here you can see we have two different distinct kind of swells, and actually this is a pretty interesting pattern. This is kind of rare almost, but you can see again that where we match up in the shape and the period and everything, energy density is the same. So yeah, so let's go on to our final trial. We have another interesting kind of pattern going here, so we'll do 191. Alright, so here's our final plot. You can see that again we display this swell here, we have this swell as well. You know, the shape is the same, we have the same energy density, so I believe that confirms our requirement, because we illustrate the major swells of the data, and they don't need to be exact, but they should show the same swell pattern. Basically the period, direction, and energy should be the same. So yeah, I would like to thank you for watching, and I hope you have a nice day.